Hey class, in today's lesson we're going to talk about real zeros of polynomial functions, which is found in section 2.3 part 1. Our objectives are to use long division to divide polynomials by other polynomials, and to use synthetic division to divide polynomials by binomials of the form x minus k, and finally to use the remainder theorem. Just a little vocabulary. So the function f of x equals 6x cubed minus 19x squared plus 16x minus 4 has a 0 at x equals 2 if it's graphed. That means that x minus 2 is a factor of f of x, and there exists a second degree function q of x such that f of x equals x minus 2 times the q of x. We can find q of x using long division. All right, so just as we mentioned in the last function, with this function 6x cubed minus 19x squared plus 16x minus 4, we can use the factor x minus 2 to find the other polynomial that could continue to factor this out. So what we will do using long division is we will take x minus 2 on the outside and we'll divide it by 6x cubed minus 19x squared plus 16x and then minus 4. Okay, with that being said, the first thing that we focus on is our x. So we focus on that x and that 6x cubed. So essentially what we do is we say 6x cubed divided by x. Well, 6x cubed is the same thing as 6 times x times x times x divided by x. So only an x cancels and we're left with 6x squared. And essentially the rest of what we're going to do is kind of mental math. So this becomes 6x squared. Then we're going to multiply. So we're going to take 6x squared and multiply it times x and multiply it times negative 2. So that will give us 6x cubed and negative 12x squared. From there, we do opposites. We're going to create the opposite of the original. So whatever was positive is now negative. Whatever was negative is now positive. These cancel, and what's left over is negative 7x squared. Just like regular longhand division, we drop down our next term, and then we start the process again. So again, this time we focus on x and negative 7x squared. So if I divide them, I have negative 7x left over. And then I multiply, so that gives me negative 7x squared and positive 14x. Sorry, that's not a squared. Okay, change our signs. This will leave me with 2x and then drop down our negative 4. Finally, we're going to focus on x and 2x. So 2x divided by x is 2. And then we multiply, so 2 times x is 2x. 2 times negative 2 is negative 4. Create our opposites, so we're done. This equals 0. So our factor, when divided completely, our answer is 6x squared minus 7x plus 2. All right, let's look at our next example. Again, we want to continue to divide. This one is a little trickier because we're going to have some gaps, and I know that I have gaps. The first one is x minus 1. It's being divided, or we're dividing x cubed minus 1, but technically x cubed minus 1 is actually x cubed plus 0x squared plus 0x, and then finally minus 1. There are gaps in this one, so to ensure that we divide correctly, you need to be sure that you focus on the gaps. All right, so with that being said, here we go. If I divide x cubed by x, that's going to leave me with x squared, and then I multiply. So x squared times x is x cubed. X squared times negative 1 is negative x squared. And then I do my opposites. Okay, that leaves me with x squared, and then I add 0x. All right, start over. Now I'm going to focus on x being divided by x squared. So, or x squared divided by x. X squared divided by x is x. And then I multiply. So x times x is x squared. X times negative 1 is negative x, and then we do our opposites. What we're left with at this point is just x, and we bring down our final minus 1. Finally, how many times does x go into x? Well, x goes into x one time, and then I multiply. That gives me x and negative 1. I create my opposites. They cancel, and I'm left with 0. So my answer is x squared plus x plus 1. Now we're going to divide, and this time we're going to have a remainder. So let's focus on how we will write remainders. Okay, so what we have is x squared plus 2x minus 3. And we are dividing 2x to the fourth plus 4x cubed minus 5x squared plus 3x and then minus 2. Okay. So if I focus on my first two steps, that will leave me with 2x to the 4 divided by x squared. That leaves me with 2x squared. And then I need to multiply, so it leaves me with 2x to the fourth and then plus 4x cubed. Sorry, this is a cubed. 4x cubed and then minus 6x squared. Remember, create your opposite. So this is a negative, this is a negative, and this is a positive. I am left with, in a new color, I am left with x squared. And then I drop my next term, which is positive 3x. Again, I'm focusing on x squared and x squared. So x squared divided by x squared is going to be 1. So positive 1. And then I multiply, so it gives me x squared plus 2x and then minus 3. Because I don't have a number in front of that minus 3, I'm also going to drop down my minus 2. That way it has a number to go with it. And then we do our opposite, so negative, negative, positive. I am left with x, because 3x minus 2x is x, and then negative 2 plus 3 is positive 1. This number here is going to be our remainder. So to write this as a final answer, we will write it as that it equals 2x squared plus 1, and then plus x plus 1 over what we were dividing by, which is x squared plus 2x minus 3. So it becomes a fraction. And again, that second half is our remainder. All right, so synthetic division follows this pattern that you're going to see here. It's easier if I kind of just explain it as we write, but essentially it's set up as the diagram shows. And so it kind of follows like a vertical / diagonal. The main thing I just want to remind you is that when you have vertical pattern, you're adding, and diagonally you multiply. So on the first one, if we have x plus 3, the first thing that we have to determine is what is the number that goes in the box. So the number that goes in the box would be if I set that x plus 3 equal to 0, which gives us a value of negative 3. So negative 3 is a number that we're going to choose to put into our synthetic division box. And then from there, we write the coefficients of our polynomial, but you need to be sure that there are no gaps. Any gaps need to be filled in with zeros. So our first coefficient for x to the fourth is 1, so I'm going to put a 1. There is no x cubed, so I'm going to put a 0. X squared is negative 10. X is negative 2. And then the no power, or the constant, is 4. Now we're done with that part, so now we start our process. So we drop our first number, which is 1, and then we begin. So remember, diagonally you multiply, vertically you add and subtract. So diagonally I'm going to multiply negative 3 times this 1 at the bottom. So negative 3 times 1 is negative 3. Vertically, if I add that 0 plus a negative 3, that gives me negative 3. And then I start over. Negative 3 times negative 3 is positive 9. If I add that vertically, it gives me negative 1. Again, if I multiply diagonally, negative 3 times negative 1 is 3. If I add vertically, that gives me 1. Finally, if I multiply negative 3 times 1, that gives me negative 3. And again, if I add vertically, that gives me 1. So what this will mean is we will take these numbers, and they now become our coefficients, minus 1 power. So originally it was x to the fourth. So now this 1 represents x cubed. The 3 represents the x squared's coefficient. The 1 represents the x's coefficient. And then I have plus 1. So then what happens to this 1? Well, this 1 becomes the remainder. So it's plus 1 over our divisor, which is x plus 3. All right, so that is our final answer. Let's try another one. So again, you have to focus on no gaps. So this is, if I set x minus 1 equal to 0, then I would get x equal to 1. So if I put 1 in the box, what's left over is for our cubed, it's 1, squared is nothing, x is nothing, then my last number is negative 1. Okay, let's start our process. So 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. If our highest power was cubed, now this first one represents squares. This is x squared plus x plus 1, and we don't have a remainder, so that is our answer. Lastly, or close to lastly, it says the remainder theorem tells you that synthetic division can be used to evaluate a polynomial function f of x when x equals k. So we're going to divide f of x by x minus k. The remainder will be f of k. So what this means for us is essentially we can use, or we can evaluate a function, we can evaluate a function by subbing the remainder of the function back into itself. So what do I mean? So if we take this x minus 2, we can use this negative 2 on our box, and then we'll do our coefficients. So the coefficients for cubed is 3, squared was 8, just x is 5, and then our constant is negative 7. So if we drop this down, negative 2 times 3 is negative 6, 8 minus 6 is 2. Negative 2 times 2 is negative 4, 5 minus 4 is 1. Negative 2 times 1 is negative 2, negative 7 plus negative 2 is negative 9. So what this will leave us with is that it means that f of negative 2, because essentially we could have evaluated or we could have used synthetic division to get the exact same answer, but f of negative 2 equals negative 9. So negative 2, negative 9 is a point on the line f of x equals 3x cubed plus 8x squared plus 5x minus 7. So again, we did all of that just to prove that it is a point on the function, along the function. Anywho, we are done. If you guys have any questions, please be sure to come see me for tutoring.